Hello everyone, welcome to another video in the Advanced SQL series. Today's topic is explain plan. And an explain plan is an idea or a plan that your optimizer has to execute the query in the database. So essentially it's a sequence of steps that the optimizers will do in order to provide you with the result set. So it helps you to understand what is the order of the operations, what are the access methods to the data, what join algorithms are used, and when the data operations like sort, filter, and aggregation are conducted. Now, if you have not seen my video on join indexes or join algorithms and indexes, a link to one of these videos will show up on the screen now, and in the description you have also a link to the other video. So I would recommend, if you have not watched them, now pause the video and go watch the other ones. Now, one remark to this video. This topic, or rather the implementation of it, will be DBMS specific, and I will be using Oracle 21C Express Edition. So basically, the way the explain plans are presented will differ between different DBMSs, but the general concept stays the same. So essentially what can be different is like how this is presented, the graphical representation, the details can be different, how you generate it can be different, but it should be very simple to find in the documentation of the DBMS that you are using. So without further ado, let's jump into SQL Developer and let's get started. So let's write a query, right? So let's say, by the way, I'm using the HR sample dataset or a sample schema. I will leave you a link in the description to an SQL file where you can just paste it in your SQL Developer, execute, and it will create the schema and insert data into it. So let's write this query, right? So first name, last name, from employees, right? So this is just a table that has some employees data. Doesn't really matter what's inside the tables for us. Now you can get an explain plan of this query in a very simple way in SQL Developer. You just click here. And then we have this graphical representation of how the query will be executed. So the XML, other XML information I will close. So as you can see, basically it's very simple. What it says is that it will access an object that's called employees. We know that's a table. And then it's using the full option. So it's performing a full table scan. So this is just going one by one through all the rows. If you don't know what a full table scan is, I would refer you to my video about indexes. So now, this is a way, but this is an SQL developer specific way, right? So if you work with Toad, if you work with DBBware or any other tool, or maybe just a command line interface, this will not work, right? Because you won't have this button. So what do you do then? You do something very simple. You say explain plan for, and now you run this. And now it just said explained, right? And the query was not executed. So with a select, it does not matter that much, but if we had a delete, update, or an insert here, then it matters that in such a case, the query is not executed. And now essentially you have two options. So to see the explain plan, right? Because currently we don't see anything. You can say select star from plan table, and the name of this table may be different for you. This is the default name. So if in your database it has been changed, then you need to figure out what's the table name. But you can run something like this. And then here you get all the sea of information that you have, right? But essentially, so if you want more advanced information, you have to use it, right? You have to use this table. And I currently have here many rows because I've been testing some things before the video, but you'll most likely see here only one row in your table. And here you have all the information of the query, right? So what it does, so really all the information that you can have, or majority of the information. However, there is also a much simpler way. So essentially what we can do is we can say select star from table, and now this will be a table function. So we need to put it inside table, DBMS _ explain plan package, and we use a display procedure from it. And now we run this. And what it does is it shows you the explain plan of the last explained statement, right? So if I once again explain this, here I still see, I still see the same thing because nothing has really been changed here. So here the plan table shows you all the queries that were run, and here you can see the statement ID. So if you really wanted to use it, what I would recommend is say explain plan and then set statement ID equals, I don't know, my ID. Now we run this part, and from the plan table you select everything where statement ID equals my ID. Right, and here you run this and you have your explain plan. So it will have 2 rows, not one, as I said. But this is just a difference, right? So here, if this would be much harder to use, you would need to parse this if you will have multiple steps, because actually you would need to combine them using here the parent ID and ID, right? To figure out like what's happening and what's executed before and after what. This is why this provides with this graphical representation, just makes it easier to read if you just need the basic information. And this is what we'll be using for the rest of this video. Okay, let's remove everything. This query is too simple. Let's try to do something a little bit more interesting. So now let's try to say select last name. And let's make a join to departments. By the way, here you can see the tables. And department name. Right, and we want to select it from, say departments, and the alias D. And then we want to inner join employees. Let's give it an alias E on e.department ID. Oops, department ID equals d.department ID. Okay, we run this query, right? So I just run the query and we get the results. However, we don't see what happened, right? So for example, we don't know what join algorithm here was used. In order to get it, we need to go in here and say explain plan for, execute it. Okay, explained. And then once again, we say select star from table DBMS explan.display. And we execute this part. And now what we see? We see something a little bit more interesting than in the previous example, because we have the join, right? So we can take a look. And here, by default, the most indexed operations are executed first, right? So we start with an index full scan. So it's like everything from the depth IDPK, right? And if you can take a look in the indexes, here we have depth IDPK, right? So this is an index, which is a primary key. So, okay, we select everything by an index, and then most likely to have it sorted already. Using these row IDs from this index, we access all the rows from the table, right? And the advantage is that because we retrieved it from an index, it's already sorted for us, right? Because the data is in the leaf nodes of an index is stored sorted. So it's already sorted. And here at the same time, we have a full table scan of the employees table. So we just go to this, create it row by row, and retrieve it. And then we need to sort it, right? Because here the data is not stored in a sorted way on the join key, right? So here, okay, we already have it, then we sort it, right? And here we access it at the same time from the departments table, but already in a sorted way. And then we can do a sort merge join, right? So an input to this join is an output of this and an output of this, right? And then just a select statement at the end. And this is basically how your query is executed, right? So here you can see, for example, okay, this join condition was used. And then, for example, if you don't like it, if you think that, okay, something is off, you felt like another algorithm should be used, you can think about, okay, why, right? Let's currently try to change something, right? So let's here change the inner join to a right join. And once again, I executed it, and I'll execute the explain plan. And what you can see right away is that we have a change of the explain plan. We no longer have a sort made join, we have a hash join, right? And this time we just do a full table access of the employees table, full table access of the departments table, and we are doing hash join, right? So the type of join that we have changed here resulted in the change of the underlying algorithm that executes this query, right? So now currently this query is executed completely different. We access all the rows from the departments table, access all the rows from the employees table. We built a hash table, most likely with the smaller table, so most likely with the departments table. and then we probe it. So we look for all the values from the employees in the build hash table, right? And this is how we perform the hash join. And how actually a database comes up with this. So it calculates different possible plans for this query. It has this here, it has this cost, which basically what the cost here means is in Oracle, and this will be different, is like a weighted value of IO cost and CPU cost, right? So you should, it's not like it has a unit. You can just use it to compare different plans, right? So currently it has a cost 6. It doesn't really mean anything. But if we then have a plan that has a cost, I don't know, 12, you just know that it's more. And here we can also see it's bytes, basically how big our results are, estimated results, because this is important, in bytes. And here we can see how many rows the database thinks it will return, right? Here we also have a time. The problem with the time is that a minimum time is 1 second. Therefore, it's not very useful for queries that take a fraction of a second, like 0.03 of a second, right? So it will always show 1 here. Now, how do the database know these changes? So it doesn't know it. It uses the statistics that it has about the table. So database keeps a number of statistics about the table. If you want to look them up, you can, in SQL Developer, you can just go in here and take a look at the, here in the statistics tab, right? And now you basically see, okay, what statistics does the database have about this countries table, right? Can I change the table? Probably it will have slightly different values here. And based on these values, the database calculates a number of plans and then chooses the one with the lowest cost. This is this simple. Okay, let's maybe try to make a different example, right? So here we already had a join. Let's currently try to do maybe some aggregation, right? So we'll select job ID. And then in the job ID, in this table, we have a salary. So I will just try to select an average salary of a job ID. So I'll say from employees. And then I will group by job ID. Job ID. Here I will select also, let's say, count star. Okay, I'll execute it. And we have results, right? So we have job ID, then we have average salary, and then we have a number of people who work on this job. So now here, let's then explain plan 4. Let's execute it. Okay, explained. And let's select everything from our plan table. So what you can see here, right, is essentially very similar structure. Okay, we have full table access for employees. So we read all the data from disk to memory, right? The database thinks it will have 107 rows and the following number of bytes, right? And then we have a hash group by, which is just a grouping by algorithm. It is performed at a certain cost, and then it ends with the select statement. Yeah, so once again, you can see, okay, how this query was executed. And then let's do one more example, right? So this will actually be the most, I think, interesting. Let's maybe try to do a join on the 3 tables. So I have prepared it beforehand a little bit. Let's select, and I will be selecting. I'll be selecting first name for employees table. This is why I say e dot. And then also the last name for employees. And then I will have 2 tables that I will join. I will select department name. And then I will select also the country ID. I wanted to give this an alias L instead of I. So from employees, E. And now I will left join departments table, D, on D dot department department ID equals E dot department ID. And now I will left join an additional table. This will be the locations table, L, on D dot location ID. So in the departments table, we have a location ID column, and we are setting it equal to location ID from the locations table. And I will end this. So I'll execute this. This works, right? We get some results. However, what we are interested in is the explain plan. So explain plan 4. Okay, query has been explained. So now we can look up the results. And what we can see here is already a little bit more complex query, right? So we can see here, we have what? We have a full table access on the employees and full table access on the departments, right? So we really read all the rows from these tables, and then we make a hash join, right? So we make the hash table of one of these tables, and then the join is performed. And then what's happening is the output of the ID2 operation and ID5 operation, because they have the same indent level, and the ID5 operation is a full table scan of the locations table. So it takes this, one of these becomes a hash table, a different hash table, most likely this, because the database thinks it's smaller in terms of bytes, much smaller. So it creates most likely a hash table out of this results of the whole locations table, and performs a hash join of the two results, so of this and of this. And then we have the final result. Let's maybe try to add a where clause. So let's say where country ID equals UK. Whoops, UK. I'll execute it. Let's try if it changes anything. And you can see already we have a totally different explain plan, right? So here we have index full scan on the locations primary key once again, right? Index full scan and then all the rows from the locations table. And here full table scan of the departments and a sort, right? So before this sort suggests already should tell you that, okay, there will be a sort merge join, right? Because this is sorted, so this also needs to be sorted. So here the results were sorted, we can now do a sort merge join. And after this, so after this is done, we have a hash join, right? Of the full table scan of the employees table and the results of this sort merge join, right? So results of this, right? So here the results are most likely smaller in terms of bytes, therefore most likely they become a hash table here, and we will be looking for all the rows from the employees inside the hash table. And this is how we perform a hash join, and then once again select statement at the end. So this is it with the explain plans. Maybe we can just shortly go to the plan table, right? I'll just execute this. Okay, currently I'll have many things here. But what you can see here is currently here we have many information. Only very limited information I provided with the DBMS expand.display procedure. However, these are the information that you'll need in 90% of cases, right? So if you really need advanced information, right, you can come in here and then you can, for example, see, okay, the detailed cost breakdown, how it differs between CPU and IO cost, like what's the projection of columns, and also other attributes or other properties of the query. And once again, I briefly mentioned this already before, you need to have up-to-date statistics of the table, and you can update the statistics manually, or you can have a process in the database configured that updates the statistics. But however, you need up-to-date statistics so that the database can judge the effort it needs to perform certain actions correctly. Because if these are completely out of date, and they are completely different than your contents of your table, the database will just select suboptimal algorithms to perform the operations. And as a result, really when it comes to like dealing with big data, because like currently we have like a few hundred rows maybe in the employees table, so it doesn't really matter. But if we had more, this could really slow down the performance, right? Selecting the suboptimal explain plan because the statistics are outdated can slow down the query like 10 times. Easy, no problem. This is why you should keep your table statistics up to date. You should update them always. If you do significant changes to the contents of the table, I know if you change more than, let's say, 20% of rows, you should update the table statistics. This is of course not a set in stone rule. Yeah, but this can be, say, a ballpark estimate of what you should do. Okay, for today's video, a little bit quicker one. I hope you learned something today. If you did, please leave a like button. Now, on different DBMSs, you would be accessing these explain plans different. So, for example, in Postgres, you would just explain and then the query, and this would display you an explain plan also, which in my opinion is then a little bit better presented in Postgres, but this is just personal preference. But if you access the documentation of your DBMS, then you should be able to find this topic very easily, and you should be able to easily use it. And I hope that from now on, you will really understand what your query is doing. And this is really the first step you should take if you want to optimize a query, because in order to optimize it, you need to understand what's happening underneath. So once again, thank you all for watching, and I will see you in the next video from this series or from any other series.